Alrighty, today the lesson is titled Conditional Statements, but this is actually two lessons combined. So not only are we talking about conditional statements, we're also talking about reasoning, inductive reasoning, deductive reasoning. So there's a big, well, it's not an essential question today. It's questions. So you might want to pause here and get your questions written down and then come back and let's start with our vocabulary as we always do. What kind of reasoning is based on patterns? That would be inductive reasoning. Inductive reasoning. If you observe a pattern and then you make a conclusion or a conjecture, as we call it in inductive reasoning, then you've used inductive reasoning if you base your conclusion on a pattern. What is the process of reasoning logically from given statements or facts? That's deductive reasoning. Deductive reasoning. And this is the one that we are mostly concerned with because patterns sometimes don't repeat, but facts never fail you. So we will be primarily concerned with deductive reasoning, but you do need to know the difference. What is the conclusion you reach using inductive reasoning? We just call that a conjecture. Sometimes you might hear us talk about a conjecture related to deductive reasoning, and that's okay, but typically we call those conclusions when we're talking about deductive reasoning. Okay, and if I'm looking for an example that proves a conjecture or a conclusion to be false, then that's known as a counterexample. We'll do lots of examples here in a minute to clear all this up for you, so don't worry if you're being overwhelmed at this point with new terms. A type of logical statement that has two parts, a hypothesis and a conclusion, that's our conditional statement. That's a conditional statement. So the statement will be if something, then something. All right, so if, the if part contains our hypothesis and the then part of the statement contains the conclusion. So if it is sunny outside today, then I will go to the pool this afternoon. That's a conditional statement. It's also known as an if-then statement, and the hypothesis is it is sunny this afternoon. You don't include the if in the hypothesis, and the conclusion is I will go to the pool this afternoon. All right, so the if, this is kind of repetitive here, the if, everything after the if is the hypothesis. Everything after the then is the conclusion. All right, and the way we write this in symbols, a conditional statement in math, we would write this conditional statement this way. And P, of course, would be our hypothesis. This is standard nomenclature for logic in math. Q would be our conclusion. So this statement right here is if P, then Q. That's how you would read that. Or you might hear it P implies Q. The conditional statement, if P, then Q. So if you think about the conditional statement I just told you, if it is sunny this afternoon, then I will go to the pool. P, the P would be it is sunny this afternoon, and the Q would be I will go to the pool. So we're just taking words and we're turning them into symbols, which is what we do every day in math. Okay, so what if I take this conditional statement, if P then Q, and I switch the hypothesis and the conclusion? So if I do that, what I'm saying is if Q then P, right? That's switching. I'm just switching places with the hypothesis and conclusion, and that is known as the converse. And you definitely must memorize these terms and know them well. So if I switch the hypothesis and the conclusion, then I've got the converse of the conditional statement. All right, what if I negate the hypothesis and conclusion? What does negate mean? Negate just means I make it a not statement. Okay, a negation means a not statement, and you'll see the little squiggly there will denote that I'm negating something. So if I do that, what I have then is the inverse of the conditional statement, and so my conditional statement is if P then Q, but if I negate both of those, then that's going to be written that way. If not P, then not Q. And finally, if I negate the hypothesis and conclusion of the converse, okay, so here's the converse. Here's the converse right here. So if I negate both of those, what I have is if not Q, then not P, and that's known as the contrapositive. Contrapositive of the conditional, whoops, spelled it wrong, contrapositive. Okay, got to remember those. All right, now, this statement here, when two statements, and I'm talking about two conditional statements, are either both true or both false, then they're known to be logically equivalent. Also, they have the same truth value. Okay, this is a very important concept. If two statements both have the same truth value, in other words, they're both true or they're both false, then we call them logically equivalent. And now I'm going to make a little note down here. I hope you have enough room here. There are pairs of these four statements. We've got the conditional, the converse, the inverse, and the contrapositive, and there are pairs that are logically equivalent. So the conditional is, and I'm going to abbreviate logically equivalent with LE in the interest of time. So the conditional statement is logically equivalent to the contrapositive. And the converse, and this is always, always logically equivalent to the inverse. So in other words, if I give you the inverse, an inverse statement, I know that the converse will have the same truth value. If I, let's take our example we did a minute ago. If it is sunny this afternoon, then I will go to the pool. Okay, the converse of that would be if I go to the pool, then it is sunny this afternoon. All right, well, those two aren't necessarily logically equivalent, but the inverse of that statement would be if it is not sunny this afternoon, then I will not go to the pool, and that would be logically equivalent to the converse. All right, very important things here that you have to remember. Here are some examples. Write the three statements below as conditional statements. 3 points are coplanar if, oh good, I've already got my if, so that's my hypothesis, and I want to put it in the beginning. If 3 points lie on the same plane, you always want to put a comma after your hypothesis, and we got to have our then, we got to have the if, we got to have the then the points are coplanar. There we go. Number 2, water freezes at temperatures below 32 degrees Fahrenheit. I'm just going to start with the first part here. If water is frozen, then the temperature is, instead of, well, I'll say below, is below 32 degrees Fahrenheit. Okay, could I have said if the temperature is below 32 degrees Fahrenheit, then the water is frozen? Yes, even though those two statements are converses of one another, in that case, they would both be true. So it doesn't really matter which I make my hypothesis and which I make my conclusion. Sometimes it does, though. So you have to be careful. Why don't you pause and try to do number 3 yourself? What you're going to come up with is if a number is even, then it is divisible by 2. And what would the converse of that say? It would say if a number is divisible by 2, then the number is even. And in that case, just like number 2, the conditional statement and the converse are logically equivalent. That's okay. They don't have to be, but sometimes they are. So in this case, number 2 and 3, all the 4 statements, the conditional, converse, inverse, contrapositive, would all have the same truth value, but that does not always hold true. It just happened to here. Remember, guys, as you go along, if you have questions or concerns, put them out here in this area. Write yourself a note, put a star, whatever you need to do to remind yourself that you need to talk about this in class. So we're just reviewing here a little bit. So if I negate the hypothesis and the conclusion, that gives me the inverse. If I switch the hypothesis and conclusion, that gives me the converse. If I take the inverse of the converse, that gives me the contrapositive. Got to remember those. And there's a really great chart on page 91 if you want to make that onto an index card. Anyway, however you do it, you got to remember it. Okay, we got some more examples. This would be a good time for you to pause and do these for yourself. So go ahead and pause. I'll fill them in, and then we'll come back and discuss. Okay, I actually went on down and did all the examples on this page. So if you did not do that, go ahead and finish this page and then check these. So our conjecture or our conditional statement says if the sun is shining, then we are not watching TV. So typically we call our conditional statement if P then Q. We could have said, this was a little tricky because we already have not in the conditional statement. So we could have called this if P then not Q, but everything else still would have been okay. But I'm pretty much always going to call our conditional statement if P then Q. So if I want the inverse of this, I'm going to have if I negate both the hypothesis and conclusion. So I've got if not P then not Q. So that's just going to say if the sun is not shining, then we are watching TV. So you just got to remember 2 negatives make a positive, right? So if I'm negating this not right here, then that makes it positive. And the converse, I'm just going to switch the hypothesis and the conclusion, and the contrapositive is the negation of the converse. All right, so make sure you got those okay. Put yourself a question mark here if you need to ask about it in class. And the next example, the conditional statement says, if my allowance increases, then I can save more money. Of course, we label our hypothesis as P, our conclusion as Q. And so the inverse, just like before, would be if not P, then not Q. The converse would be if Q, then P. I have a feeling the contrapositive is going to be on the next page. So let's make sure I remember this. If my allowance increases, then I can save more money. So yep, here's the contrapositive. So it is if not Q, then not P. So let's see, Q was I can save more money. So if I do not save more money, there's not Q, then, and here's not P, then my allowance, oops, got a problem there. My allowance did not increase. Okay, and don't forget which of these are logically equivalent. Contrapositive, logically equivalent to the conditional statement. Converse and inverse, logically equivalent. meaning they have the same truth value. Okay, let's go here so we can do some examples with our postulates that we learned in Unit 1. Through any 2 points, there exists exactly one line, right? If 2 distinct lines intersect, then they intersect in exactly, this is review, 1 point. If 2 distinct planes intersect, then they intersect in exactly one what? Line. Planes intersect in a line. And through any 3 non-collinear points, there is exactly one plane. So let's do an example using those postulates there. All right, we're going to decide whether the statement is true or false. If it is false, give a counterexample. Okay, well, if we can find even one counterexample to any statement, then we just say the statement is false. So how about this? A point can lie on more than one plane. Well, of course it can. That's true. That's true because if you think about the intersection of 2 planes, it's a line, and this point, every point that's on that line is on both planes, right? So a point can definitely lie on more than one plane. If 2 lines are coplanar, then they intersect. If 2 lines, so let's pretend like here's our plane here. Got to think about this for a second. 2 lines that are coplanar. Oh, what kind of lines don't intersect that are coplanar? Parallel lines, right? They're coplanar and they never intersect. So this is false. And our counterexample is parallel lines. Okay, that was a big lesson. Write yourself a nice summary, and we'll see you next time.